Good afternoon. My name is Ms. Henry, and now we're going to discuss dosages based on weight, and specifically pediatric doses and calculation of pediatric safe doses, which are all calculated based on weight. Please refer to your rounding rules. All pediatric doses should be rounded to the nearest 100th. An example of a pediatric dose would be 3.458. That would round to 3.46. You wait and round with your final answer on all pediatric medications. Doses based on weight. Safe medication administration of doses are based on milligrams per kilogram per day. Another important factor to consider is the number of equally divided doses to be administered in 24 hours. The things that you need to calculate a safe dose are: you need to look at your order of dose of medication ordered, you need to verify that order, you need to look up in the drug book and look at the safe dosage range, you need a client's current and accurate weight converted to kilograms. You need to know the number of doses to be received in 24 hours. Example, sometimes you will have an order that says give ampicillin every 6 hours. 24 divided by 6 hours, that would be 4 doses in a 24-hour period. That can be an important point. It is your legal and professional responsibility to not just give what the physician has ordered on a child or any weight-based drug, but it's your responsibility to look up in the drug book the safe dose range and calculate for yourself to see is it safe or not. One of the first steps is, of course, to get your child's weight. If it's in pounds, you need to convert that to kilograms. Always remember that if you do this conversion correctly, you should always weigh less in kilograms. First, you will convert pounds to kilograms by dividing the weight in pounds by 2.2. Example, if you have a child that weighs 42 pounds, you say 42 pounds divided by 2.2 equals 19.09 kilograms. Am I going to do anything with 19.09 kilograms? No, I'm going to leave my kilograms at the 100th place and calculate it like that because it can make a difference in the dose. Let's now work through a problem of converting a child's weight. Child's weight in pounds divided by 2.2, again, will equal your weight in kilograms. You need to always verify your order, get your pediatric client's current weight, get your drug book and calculator, and let's go calculate the dose and see if it is safe or not. Now let's look at an actual problem. We have an order to administer Keflex 125 milligrams every 6 hours. The recommended dose in the drug book is 25 to 50 milligrams per kilogram per day. Anytime that you have a range, you will take the larger number, in this case 50, and that is what we will use to calculate. Our child's weight is current and it is 42 pounds. We need to convert our weight of the child to kilograms. 42 divided by 2.2 equals 19.09 kilograms. Do not round your 19.09 kilograms. Next, we need to determine the number of equally divided doses to be given in 24 hours. Our medication ordered is every 6 hours. 24 divided by every 6 hours equals 4 doses in a 24-hour time frame. We take the larger number of the numbers in the recommended dose range of 25 to 50 milligrams per day and multiply the client's weight in kilograms by that largest number. So in this case, the child's weight in kilograms is 19.09. We're going to say 19.09 times 50 milligrams, the larger number that we found of our recommended dose in our drug book. 19.09 kilograms times 50 milligrams equals 954.5 milligrams per day. Now remember, this is per day, is a safe dose. Now we divide the milligrams per day by the number of doses to be received in 24 hours. In this case, we had determined that was 4 doses. So 954.5 milligrams per day divided by 4 doses will equal 238.62 milligrams per dose. Is that a safe dose? I believe we had ordered 125 milligrams. As long as your dose that you calculate, as long as the dose that is ordered is equal to or less than your dose that you calculated is safe, it is a safe dose and you can administer it. 125 milligrams every 6 hours is the dose ordered. 238.62 milligrams was a safe dose according to the literature and calculations. Once again, 125 milligrams was less than 238. The dose ordered is a safe dose. Now you can proceed to calculate how many milliliters you will actually give. Our dose to be given is 125 milligrams. We have available 125 milligrams per 5 milliliters of suspension. We will give 5 milliliters. How did we arrive at that? We look at our label, and that's always the first step in your dimensional analysis. We have 5 milliliters and 125 milligrams in that 5 milliliters. We want to give 125 milligrams. So, how many milliliters are we going to give? (125) times 5 equals 625 divided by 125. So 625 divided by 125 equals 5 milliliters. So that's how much suspension you would deliver for this medication is 5 milliliters. Now let's practice, 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 and work another problem. We have an order for amoxicillin, 250 milligrams every 8 hours to be given. Our client's weight is 30 pounds, and we verify that it's an accurate weight and a recent weight. We convert our 30 pounds to kilograms by dividing 30 divided by 2.2. We get 13.64 kilograms. We look in our drug book and we find out that the recommended dose is 6.7 to 13.3 milligrams per kilogram every 8 hours. So we take the larger of the two numbers, 13.3 milligrams, and we take our weight in kilograms, 13.64 kilograms times 13.3 milligrams equals 181.41 milligrams every 8 hours. In this case, we do not have to divide by the number of doses because our drug is ordered every 8 hours and our recommended dose is given for every 8 hours in the drug book. 250 milligrams is ordered. This would not be a safe dose. Why is that? Our safe dose is 181.41 milligrams every 8 hours. So we would not give anything that was greater than 181.41 milligrams. And the physician has ordered 250. What would we do? We call the care provider. We do not administer it.